Let's study the surface area of the ellipsoid. This is an ellipse on the Cartesian plane. The side B is, in this case, the minor semi-axis. C is the focal semidistance. Pythagoras' theorem would apply this way. This is the ellipse equation. Let's factorize b squared. Now let's factorize a squared. Let's differentiate. The derivative of b squared times x squared is 2 times b squared times x. The derivative of a squared times y squared is 2 times a squared times y times the derivative of y with respect to x. The term on the right is a constant, thus its derivative equals 0. Let's move the first term in order to be subtracted. Let's move the second term in order to be divided. The 2's are simplified. If we raise both expressions to the second power, we get b to the fourth times x squared over a to the fourth times y squared. Let's call this value y prime of x squared. Now, let us consider Pythagoras' theorem. Let's move the b and calculate the square root on both sides. Let's divide both sides by a. Let's call this expression xc. This quantity, xc, is called eccentricity. This expression is the formula to calculate the surface area of a solid of revolution which rotates 360 degrees, or 2 pi radians. Given that this is an ellipsoid of revolution, it is more appropriate to call it spheroid. Let's substitute the value of y prime of x squared for the value we computed previously. Let's operate. We may take the y out from the square root and from the integral. Oh, it was simplified. We may also take a out. Upon leaving the square root, it becomes a squared. Let's bear in mind this expression. Let us consider that b to the fourth power is b squared times b squared. What for? For factorizing. Let us replace this b squared with the expression obtained from Pythagoras' theorem. Let us expand the factor. Let us consider a to the fourth as a squared times a squared. Let us factorize this a squared. Do you remember the ellipse equation? Let's substitute it. Let's multiply. Let's factorize b squared. We may now put it out from the square root. Let us consider again a to the fourth as a squared times a squared. If we factorize this way, we may take it out from the square root. The a's are simplified. We may notice that the expression c squared divided by a squared appear. This expression is equivalent to c squared. Let's replace it. If we factorize c squared, we get the following expression. Now we may take c out from the square root. This integral is similar to a non-one. It is an integral which is solved by using trigonometric methods. This is a result. In this case, h equals a over c. When we substitute it on our previous result, we get the following expression.